I just said that MySQL is a free and open source database, but some of you may be yelling, isn't MySQL controlled by Oracle now? And you would be right. But Oracle does publish the MySQL Community Edition, which is free. This is what you get when you run sudo apt-get install MySQL server. Still, because some people don't like the influence that Oracle has over the database, there are a number of popular forks. These forks either try to improve performance, improve licensing, or both. First up on our list is Percona. Percona is a company that makes a database called Percona Server, which is advertised as a free, fully compatible drop-in replacement for MySQL that provides superior performance, scalability, and instrumentation. They attempt to stay up to date with the patches from MySQL Community Edition, and they match the version number of MySQL. Installation is pretty simple. You add the Percona Server apt repository, apt-get update, and then install Percona Server 5.6. Everything else should work identically to how you would interact with MySQL. This is a pretty easy replacement for MySQL, and it's kind of a no-brainer, unless you're using something like Amazon's RDS service, which only supports MySQL Community Edition and does not support the Percona fork. Next up, we have MariaDB. MariaDB is still MySQL compatible, but it is a slightly larger departure from the MySQL Community Edition. They have their own version numbers that are different from MySQL, and they've made more changes as compared to the Percona fork. It's still a popular database, and the installation process is very similar to Percona. You pick your distribution, release, and version, and you'll get a link to the appropriate repository. You'll simply apt-get update, and then install MariaDB server. While it might be a little more work, and you might be taking on a little more risk versus just using the default MySQL Community Edition, MariaDB is another viable option as a MySQL fork. Finally, we have WebScale SQL. WebScale SQL is a collaboration between Google, Twitter, Facebook, and others to make a highly performant MySQL branch. They are very explicit about being a branch and not a fork of MySQL, since they are very close to the public MySQL 5.6 Community Edition. The downside of WebScale SQL is that if you want to run it, you're going to be compiling it from source. They don't publish packages for popular Linux distributions. While WebScale SQL is without a doubt a performant and excellent alternative option, it's only really viable if you have dedicated database administrators that are going to make sure it stays stable and is easy to install in your environment. Given all of the above, for a normal site, I'm going to recommend that you choose either MySQL Community Edition or Percona, depending on your environment. As I mentioned, Percona is not supported on Amazon's RDS, so if you want to use that, you're stuck with MySQL Community Edition or MariaDB. If you plan on running your own server or plan on installing MySQL on an EC2 instance in Amazon, Percona is a great alternative. Now that we have settled on MySQL, let's talk about how to configure it to make it as fast as possible. If we look at our Vagrant box, we'll see that we have MySQL version 5.6 installed. And this is actually the Percona fork, even though you can't see it here. The way you can tell is by logging into MySQL and running show variables like version. In the version comment, you'll see the exact release and version number of the Percona server build that you're running. The configuration for MySQL lives in the /etc/mysql/my.cnf, and this is where we will edit all of the variables that we need to change to keep our MySQL instance fast. If you have read about MySQL performance before, you've probably heard people compare the two main MySQL storage engines, InnoDB and MyISAM. Starting in MySQL 5.5, the default storage engine is InnoDB. Let's briefly compare the two. InnoDB supports row-level locking when writing data. MyISAM supports table-level locking. What this means in practice is that if you are using an application that plans on writing any data at all, like almost every single one does, MyISAM is not going to be a performant option for you. InnoDB also supports foreign keys and transactions, whereas MyISAM does not. If you want the consistency and reliability that come with foreign keys and transactions, InnoDB is a no-brainer. We're going to leave this default, and you should plan on having all of your tables using InnoDB, not MyISAM. There are dozens of variables you can configure in the MySQL configuration file, but we are going to focus on only 5. The first is max connections. You need to set this variable to a number that will cover all of the connections you expect to be making to MySQL from PHP. A good rule of thumb for this is that it should equal your pm.maxchildren, which we set in the last module, times the number of application servers that you have running in your pool. This will ensure that there is a MySQL connection available for every PHP FPM process that is running. This is a virtual machine only running one PHP FPM process, so we could reduce the number of MySQL connections, but it's not going to hurt to leave the default of 100 in our case. The next variable you really must set is InnoDB buffer pool size. This is potentially the most important variable to set in your MySQL config. To keep things fast, MySQL will cache data from disk in memory. The InnoDB buffer pool size tells MySQL how much memory to use for this cache. A safe value to use here is 90% of your server memory, assuming MySQL is running on a dedicated machine. As an example, on a machine with 8 GB of memory, we would set this to 7 GB. Next up, we have InnoDB I/O capacity. This tells MySQL the maximum number of IOPS, or input-output operations per second, it should use, and this depends on what kind of disk you have in your machine. Here are some starting points for a variety of common disks you may have. If you're not sure how many IOPS your disk can support, we can use the extremely useful FIO tool to find out. Let's leave this commented out and check what we have on the system. I've made a pretty basic FIO configuration that will tell us what we should use for this configuration variable. We are just going to do random reads and writes in this directory that I've created, and we can run the file and see what kind of IOPS we're getting on this machine. If we scroll up, we'll see that our read IOPS peaked at about 1600, and our write IOPS peaked at around the same number. Given that, we can safely set our capacity at about 1500, and MySQL will never use too many IOPS. The final variables we are going to tweak on our machine are query cache limit and query cache size. At face value, query cache sounds like a great thing. MySQL will cache things for us, negating the need for a service like Redis, right? Well, unfortunately, there are some issues with MySQL's query cache. The problem is that when you write data to MySQL, the query cache has to be updated so it never serves stale data. To accomplish this, anytime there is a write to the database, MySQL completely resets the query cache for the entire table that you wrote to. What this means is that if your server has a high write workload, the query cache is completely useless. The overhead of managing the cache is going to slow you down more than the cache will speed you up. If you have one server that's receiving all of your reads and all of your writes, it's probably safest to set this to 0 and do your caching with Redis. If, on the other hand, you are tuning this on a read-only slave, or some other server where the traffic is predominantly reads, you could leave it on. To make it clear what these variables actually do, query cache limit sets the size limit for a single query that MySQL will cache, and the query cache size parameter determines how much overall cache MySQL will use for all of the queries that it has in the cache. Once you have made these changes, you need to restart the MySQL service for them to take effect. If you want to confirm that your changes worked, you can look at the variable values in MySQL. And there you go. You can see that we've turned off our query cache limit. As I mentioned earlier, there are many variables you can change in your MySQL configuration file, and you can read entire books on the topic, but the few things we've tweaked will put you in a good spot for most applications.